Hello girls, I hope you're having a great day and staying safe at home. To continue with the periodic table, today we are going to learn about the modern periodic table. Now, you know in the modern periodic table, as I had already told you in the last upload, that elements are arranged according to increasing atomic number. So when elements are arranged according to increasing atomic number, the elements which have an equal number of valence electrons occur at regular intervals. So this regular intervals are known as periods. And since the number of valence electrons of elements show periodicity, that means at regular intervals they repeat, chemical properties also show similar type of periodicity. That means the chemical properties also become similar. Supposing, let us take a group of the periodic table. For example, this is the first group which I have written down. Okay, lithium with atomic number 3, sodium 11, potassium 19, rubidium 37, cesium 55, and francium 87. So when we look at these elements which belong to the first group, okay, you will see that they have similar chemical properties. All of them are good reducing agents. They have valency 1. That means they can give away one electron. So they form unipositive ions. They are very soft metals. They are very reactive. And we do not find them free in nature. You will find them only in the combined state. And when they burn, they give color to the flame. They form hydrides with hydrogen and form basic oxides with oxygen. So we are talking about the chemical properties of the first group of the periodic table. Which periodic table? The modern periodic table. And when you look at one more chemical property I forgot to mention was it reacts with water. All these metals reacts with water to form metal hydroxides and hydrogen. And if you form the electronic configuration, first 1, 2, 8, 8, 1. So you will see, if you continue, you will see that the last orbit always has one electron. Okay, the last orbit always has one electron. So that is the main cause why the chemical properties are the same. So when we look at these elements, we will notice that elements with similar electronic configuration have similar properties. So the cause of periodicity is the same number of electrons in the outermost orbit. Okay, so properties that reappear at regular intervals or in which there is gradual variation or differences, that is, there is a slow increase or decrease at regular intervals. These properties are known as periodic properties, and the phenomenon is known as periodicity of elements. And I already told you what is the main cause of periodicity. It is the recurrence of similar electronic configuration. So one thing keep in mind, children, in a group, now we are talking about the first group. That means outermost orbit has one electron. If we talk about the second group, the outermost orbit will have 2 electrons. Okay, keep that in mind. Now, in a particular group, the number of electrons in the outermost orbit remains the same. So first group has 1 electron in the outermost orbit. Second group has 2 electrons in its outermost orbit. Similarly, the third group will have 3 electrons in its outermost orbit. That means valency also remains the same. So elements of the same group have similar properties, though the number of shells increases down a group. So as you go down a group, here you can see, okay, just take a look here. How many shells are there? 2. How many? 1, 2, 3. How many? 1, 2, 3, 4, 5. So this will have 6. This will have 7. This will have 8. But the last orbit will have how many electrons? It will have just 1 electron. So Moving on to the salient features of the modern periodic table. Now, vertical column, this is the vertical column, you go down, okay? In the periodic table are known as groups, and as you move across the horizontal rows, as you move across, it is known as periods. Now, the modern periodic table has 18 vertical columns. You can see 1 to 18 vertical columns comprising of groups 1 to 8 and 0. If you take a close look at this table, you will see that group 1 to 7 are divided into subgroups A and B. See 1A, 2A, 3A, 4A, 5A, 6A, 7A. Here also 1B, 2B, 3 comes here, 4B, 5B, 6B, 7B. So till 7 they are divided into subgroups. So that makes a total of 18 groups. Now elements of subgroup A, that is 1A, 2A, 3A, 4A, 5A till 7A, that is group number 1. You can see 1, 2, then 13, 14, 15, 16, 17. Okay, they are known as the main group elements or the representative elements. Representative elements or the normal elements. They are also known as the main group or normal elements. These elements have their outermost shells incomplete. Okay. Elements of group number 3. Let me take another color. Okay. 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 were left out. Okay, so they are known as, it is already mentioned here, they are known as transition elements, and they have 2 outermost shells incomplete. Okay, and then moving on to the elements of the 0 group, that is 18, they are inert gases or noble gases, and you know inert gases or noble gases are stable because their outermost orbit is filled, either duplet or octet configuration. Okay, so only helium, in this case helium has 2 electrons, duplet configuration. The remaining, they have 8 electrons in their outermost orbit. So that is the 0. Moving on to the periods, if you see, there are a total 7 periods in all. Okay, so there are 7 horizontal rows in the modern periodic table. Each is called a period. The number of shells present in an atom determines its period. Okay, that means period 1 means it has 1 shell. Period 2 has 2 shells. Period 3 has 3 shells. Period 4 has 4 shells. Okay, so elements with electrons increasing mathematically in the outermost shell, that is 1 by 1 till an octet. So as we go across, you will see that there is an increase in electrons 1 by 1, and finally when it reaches the 0 group, that element will have 8. Okay, and again it will go back to the first period. So the last element of each period has 8 electrons, except of course for helium. Helium has only 2 electrons in its outermost orbit. Now the first period has only 2 elements. You can see hydrogen and helium. Atomic number is 1 and 2. So period 1 is the shortest period. The second and third period, this one and this one, contains 8 elements. If you count, you'll see there are 8 elements each. Okay, atomic number 3 to 10 in the second, and atomic number 11 to 18 in the third period. These are short periods, not very long periods. The fourth and the fifth period contain 18 elements each, atomic number 19 to 36 in the fourth, and atomic number 37 to 54 in the fifth period. These are pretty long periods. Okay, now the sixth period, moving on to the sixth period, it contains 32 elements in all. So sixth period is the longest period. All these longest, shortest, remember, are important for your one word answers. Fill in the blanks in section 1. The seventh period, so moving on to the seventh period, it contains 32. The seventh period contains 32 elements, atomic number 87 to 118. It is also the longest period. Okay, so in group 3b now, let's go to group 3b. So here we have group 3b. Okay, that is group number 3. If we come up here, that is group number 3. There is a set of elements with atomic number 57 to 71. Okay, there. That is known as the lanthanide series. Okay, from lanthanum to lutetium. Okay, so beginning with lanthanum, these elements are known as lanthanides, rare earth. And in group 3b, that is group number 3 of the seventh period only, there is a set of elements with atomic number starting from 89, okay, 203. You can see 203, beginning with actinium. These elements are known as actinides. Okay, so they are also radioactive elements. The lanthanides and actinides have similar properties because they belong to the same group, that is group 3b, but they are shown at the bottom of the periodic table, as I told you earlier, because they are large in number, and showing them in the main body of the table will distort the shape, or like the shape of the periodic table will not look good. Okay, now moving on to the types of elements. There are 4 types of elements. The first one is representative elements, second one is transition elements, third one is inner transition elements, and the fourth one are the inert gases or noble gases. So classification according to SPDF blocks is based on electronic configuration. Okay, this you'll be learning in your higher classes. Now the first we are going to discuss is the representative elements, that is S and P block elements. Now elements, I had already told you, they have their outermost orbit incomplete. So they include the elements of group 1, alkali metals, which form strong alkalis with water. There is an exception, which is hydrogen. Group 2, alkaline earth metals. They form weaker alkalis compared to group 1 elements. Okay. Next is group 13, which is known as the boron family because boron is the first member of the group. Moving on to group 14, which is known as the carbon family because carbon is the first member. And group 15 is known as the nitrogen family. Why? Again, by now you know nitrogen is the first member. Group 16 is the oxygen family. Oxygen is the first member. And group 17 are the halogens, which are the salt formers. Halogens, you know, fluorine, chlorine, bromine are your. The main characteristics of representative elements, they are both metals and non-metals. And there is a regular gradation from metallic to non-metallic character as one moves from left to right across a period. So in the beginning, you'll see metals, and as you move towards the end of the periodic table, you'll see non-metals. Okay. Next is they form electrovalent as well as covalent compounds. That means compounds are formed by the transfer of electrons as well as by sharing of electrons. The metallic nature increases moving down any of these 7 groups. That is, when you move down a group, you will see that the metallic character increases. Now, metals, which are good conductors of heat and electricity, you know that you will find in groups 1 and 2. Non-metals you will find in group 16 and 17, and of course you know that non-metals are poor conductors of heat and electricity. And there are some heavier metals like tin and lead which show variable valency according to the reaction or where they are taking part. They will have their own valency. It may have valency 2, 3 or 4 and so on. Now next, moving on to transition elements or D block elements. You will find them in groups 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. The main characteristics of transition elements: these are elements all with high melting and boiling point. That means they are all metals. Okay, since they are all metals, they have to be good conductors of heat and electricity. And these elements, some of these elements are attracted towards a magnet because they are metals. And most of these elements are used as catalysts. Okay, transition elements, most of them are used as catalysts. Okay, and of course most of these elements also show variable valencies. Some may have valencies 2 and 3 or 3 and 4 and so on. Okay, and most of these elements form colored ions and colored compounds. So the compounds that they form, the salt, the compounds, the solid compounds, you'll see either they are blue or green, okay, or yellow and so on. Okay, so we will stop here today, children. In the next upload, we will continue with the inner transition elements. Have a great day. Stay safe. God bless you.